Salam dostlar, axşamınız xeyir. Necəsiz? Bugün deməli 57-ci gündən davam edirik. Artıq 57 gündür işsizik. Bir dənə səs falan yoxlayım. Ardından yox keçək görək nə edirik. Abunələrimiz də 488-dir hazırda. Yəqin biraz da artar. Hala. Mikrofon səsi niyə belədir? Mikrofon səsi Test 1 2 Allah Allah. Test 1 2 Test. Niye böyle oldu ki? Test 1 1 Allah Allah. Ha, indi qaydasına düşdü. Qaydasına düşdü mü? Ha, indi qaydasına düşdü. Okay. Qaydasına düşdü. Yaxşı ki səsi yoxladım. Yoxlamasam bir də problem şəkildə davam edəcəkdik. Okay. Neyniyək indi? Heç nə, qaldığımız yerdən davam edək. Bunun açım çatı da bura bir yerdə qoyum. Səs falan artıq həll oldu qaydasında. Okay. Əla. Ekran da qaydasındadır mı? Bunu da bir dənə yoxlayaq. Okay. Baxıram. Ekran görünür. Ekran normaldır. Biz dünən qalmışdıq. Hansı hissələrdəydik? Buraları oxuduq, keçdik, DNS-ə baxdıq. Content Delivery Network dedik, Push CDN, Pull CDN, Static Content'i gətirir. Content Delivery Network bildik, CDN bildik, DNS bildik, nədir, necə işləyir, API Resolver. Gəlik Load Balancer, HTTPS-i də buna əvvəlki session yayında baxdıq. Load Balancer'da Random, Round Robin, List Busy, Sticky Session, Cookies by Request Params, Waits for... Mən buna baxacaqdım. Mənə hardadır? Gəlin bunun üzərinə gedək. Problem investigation eləyək. Görək nə eləyə bilərik. Okay. Help me to do problem investigation. investigation. Assume that I have a website and this website UI has a button. When a user clicks this button, loading happens, and after time it shows response. This system was working fine until few days ago, but now have this loading problem, and users reporting this issue. How should I investigate this problem? Where should I start, and what can I do? Boy. Things longer for better result. Bu düşünsün. Ben de orada bir tane çay süzüm. Paşan hakatondan bize qalan bu termosun xeyri dəydi. Deməli, fast nəsə danışır. Bundan nədən danışır? Okay. Here's the Crips battle-tested investigation playbook you can run right now. From triage, root cause, fix, prevention. I will bias for web stacks, React, Node, Express, CDN, but the flow is general. And başta fast triage, stop bleeding, check error, latency dashboard, front-end ROM and backend IMP, look for spikes in error rates, latency or timeouts around time user starts reporting issue. Rollback, disable future flags for anything shipped in the last few days that touches this button. Health check dependencies, auth API gate waffle, payment 3D party APIs, DB, cache, CDN, object storage, message queue. If a dependency is degraded, fail fast or show a friendly fallback. How to fix a timeout limit, user feedback on client. So users aren't stuck on infinite spinner while you investigate. Reproduce scope. What exactly broke? Browser, device, network, user state, region. Capture artifacts, HAR files, console logs, screen recordings, timestamp, user ID, the private window, and disable extensions to eliminate cache, crop proxy, ad block noises. Client-side deep dive, Is the click never reaching the API or the response is slow? DevTools network, is request sent? If no request, likely front-end logic, disable button, not even bound, early return, state guard stack, suspense boundary never resolved, promise change dropped, unhandled rejection swallow. If request in send, status. 2 ilə başlayan statusdur, yoxsa 4 ilə başlayan statusdur. TTFB high. Server slow or upstream dependencies. Content download long. Large payload. gzip. Brutal. Nədir bu? Misconfig. Slow network CDN. Course preflight. 204 and options. Any course error in console. Cookies same site. Missing session cookie on cross site. Common after recent browser changes or domain path tweaks. Response body backend error message response. Validate JSON shape versus what UI expects. Look for type error. Unhandled promise rejection. Resize observer. Look blocked by course. Fail to fetch. Nəsə belə error. Blocked by client, etc. Quick client probes. Okay. Again, backend API deep dive. APM traces. Where is the time spent? App CPU, outbound HTTP, DB query, cache, queue, publish, file input, output, error logs with stack trace around time step, rate limiting, WAP rejection, geoblocks, bot rules, auth token expires, clock skew, JWKS rotation, audience mismatch, slow query log, look for new full scan, missing indexes, logs, deadlocks, connection pool exhaustion, cache miss storm, eviction, Redis timeouts, key space growth, third party elevated latencies quota exceed, and circuit breakers. Grace for degradation. Infra regressions, CDN, new cache rule, header stripping, stale or poisoned cache, post cached incorrectly, LB ingress, new path rewrite, sticky session off, TLS certificate renewal issue. Bu niye olsun ki? Gec gəlir sadəcə, cavab bu ola bilməz. env config drift change base URL course always cookie domain same site HSTS auto scaling under provisioned code starts node drain events vesaire ilaxır. Diff what change this catches most incidents. Git log since 10 days ago, touching the button, API, auth, course cookies, bunu deyir ki, bax gör kodda nə dəyişib. Config, env, feature flag, course origin, cookie attribute. Okay, biz bildik deməli nələr ola bilər. Deməli, baxırıq notlarımıza, gəlirik bura qeyd edirik. Bir front-end button is not working. İkide if button sending request to another third party API it might have delay. If DB query is slow, it might be cause of index fragmentation. Və orada bir neçə səbəb var idi. Nə var idi bu səbəblərin içərisində? Table, çox large table, insufficient idi. Insufficient query, select star, the having clause where instead of inner join vesaire ilaxır. Ola bilər. Başqa nə ola bilər? Neyse, bəs DB deyilsə, problem başqa nə idi? DB-dən başqa. Third party dedik. Rate limiting. Cache problem necə ola bilər? Bu token expiration ola bilər. Token DB-yə getməmişdən əvvəl, onda bu buradadır. All token expired. Cache nə ola bilər? Cache cleared. Başqa. Eviction. Rate limiting. Rate limit breached by sender IP address. Belə bir şey mi? Başqa. Network issue ola bilər. O front-end'e gəlməmişdən qabaq olur. Network. Button işləmir. Buttondan bəlkə network issue. Network issue necə ola bilər? Network issue necə ola bilər? Tracing. Domain root change. Course veya cookie attribute değişikliği ola bilər. CDN start blocking or caching post due to new rule. Also can audience issue mismatched after rotating keys. Service worker shipping and older app cells calling new API endpoints. Sonra DB index dropped. Index'deki drop ola bilər də. Index fragmentation, index drop vesaire. Okay. Write an instant note, impact timeline, root cause, fix implementation. Add an automated test. Integration E2E for this exact path. Add an alert for signal you missed. communicate a clear post-mortem to stakeholder, keep users informed in app, sonra nə? If it was visible downtime. Tiny checklists you can copy. Network request fired. Method URL header body correct. Network problem bu ola bilər. Network issue. Request fired. Request fired nə deməkdir? Course precise okay. Cookie present as expected. Console errors. Spinner cleanup or error on error. Finally, service worker bypassed updated. Same build SHRA as backend expectation. Okay, network issue'da nə oldu? Nə bilim, network issue'da nə ola bilər? This is the list I created to identify problem. Can you help me to add more options? Okay, bundan əlavə server load on server dedik. Server bunu bura qoymuruq da. Load on server. Başqa. And explain one görə nəticə. Thinking longer for better answer. Düşünsün. Load this starting list. Let's turn it into complete categorized checklist and briefly explain each of yours. You can copy paste this into your NESA. Client UI, network, auth, security, backend API, DataDB, infra, CDN, DNS, third party, deploy config, background queues, observability. Expectation for the items you already list. Frontend button is not working. UI logic bug. Even handler not bounded, disabled state, never reset, stale closure, unhandled promise, rejection, prevent finally, suspense, react query, awaiting, never resolving promise, double click raise, service worker serving old GS that calls a removed API. Neyse, bu front tərəfdə olacaq problemlərin siyahısıdır. Network issue. Anything between browser, gateway, DNS failure, TLS certificate issue, proxy VPN diyəcəydim əslində ağlımda fərqə. Proxy VPN, corporate firewall, adblock blocking the domain, HTTP 2-3 fallbacks. Bu nədir? MTU weirdness, local ICP blip, inspect waterfall, high DNS connect TLS time versus high TTFB. TTFB neydi? TTFB. Time to first byte. HTTP request time, process request time, HTTP response time, TTFB. Or time to first byte is web performance metric that measures the time between user browser requesting a resource and first byte of response arriving from the server. Okay. Third-party API delay, upstream SLO breach, cold starts, throttling quota, region miss routing, new version rollout, add timeout, circuit breakers, cache asynchronous fallbacks. Neyse, third-party API'den ise problem olabilir. Authentication token expire olabilir. Token expire olduğu için. Refresh flow never runs. Log 401-403. Cache clean. CDN edge browser cache pure increases origin load. SV cache invalidation causes full reloads. E-tag mismatch breaks conditional gets, and temporary latency spikes common after purge. Rate limit reached by sender's IP. App rate limits pre-IP or per token. Ensure clear with retry after. Watch for NAT office IP causing false positives. Load on server, CPU saturation, thread worker, pull execution, connection pull starvation, garbage collection trash, container throttling, auto scaling lag, noisy neighbor on the node, neyse vesaire daha. DB query slow, bu da index fragmentation, drop large table pull query. Sales that. More cows to add organized. Neyse, burada bayağı bir şey var. Okay. Okay. Load balancer distribute incoming client requested computing resources such as application, servers, and database. In each case, load balancer returns the response from computing resource to the appropriate client. Load balancers are effective at preventing requests from going to unhealthy server, preventing overloading resources, helping to eliminate single point of failure. Can be implemented with hardware, expensive, or with software such as hub proxy. Additional benefits include SSL termination, decrypt incoming requests, and encrypt server response, so backend servers do not have to perform these potential expensive operations. Removes the need to install a certificate on each server. Session persistence. Issue cookies and route specific client requests to same instance if web apps do not keep track of sessions. To protect against failure, it's common to set up multiple load balancer either in active passive or active mode. Bu da yollarını bildik. Layer 4 load balancing. Layer 4 load balancing look at into info at the transport layer. Layer 4 hansıdır? Layer 4 transport layer decide how to distribute request. Generally, this involves the source, destination IP address and ports in the header, but not the content of the packets. Layer 4 load balancer forwards network packets to and from the upstream server, performing network addresses. Network address translation, NAT. Layer 7 deməli load balancing look at the application layer to decide to distribute requests. This can involve contents of headers nə deyir? Message and cookie. Layer 7 load balancers terminates network traffic, read message, makes load balancing decision. Layer 4 load balancer can look at info at the transport layer and decide how to distribute requests. Generally, this involves the resource, destination IP address and ports in the header, but not the contents of the packets. Layer 4 load balancers forwards network packets and packets to and from upstream server, performing network address translation. Layer 7 load balancing look at the application layer. Bu look at info transport layer. Bu look at application layer. Decide how to distribute requests. This can involve contents of header, message, and cookie. Layer 7 load balancer terminate network traffic, reads the message, makes load balancing decision, and opens connection to the selected server. For example, Layer 7 load balancer can direct video traffic to the server that hosts videos while directing more sensitive user billing traffic to the security hardened servers. Less time and computing resources in Layer 7, although the performance impact can be minimal on modern community hardware. Layer 7 application'a baxır və necə request distribute edəcəyinə qərar verir. Bu da this can involve contents of hardware, message and cookie. Layer 7 load balancer terminates network traffic, read message, make load balancing decision, then open a connection to the selected server. Və network'ü terminate edir. Terminate network traffic, read message, makes load balancing decision, then open connection to the selected server. Bu nə edir bəs? To and from upstream servers. For example, Layer 7 load balancer can direct video traffic to the server that hosts a video while directing more sensitive user billing traffic to security hardened servers. At the cost of flexibility, Layer 4 balancing requires less time and computing resources than Layer 7, although performance impact can be minimal on modern hardware. Deməli, bu da deyir ki, layer for load balancer make routing decision based on information in the TCP UDP transport layer, mainly IP address, destination IP address, source and destination port numbers, protocols. It doesn't look at the content of the request. Layer 4 request'in contentine baxmır. When traffic comes in the layer 4 load balancer, just forwards the entire packets to the one of the backend server using rules like round robin, list connection, or hash-based routing. It usually uses network address translation to rewrite IPs. Very fast, low secure usage, low resource usage, limited flexibility. Commonly used for raw TCP UDP services. Okay, imagine you have 3 backend servers. Layer 4 load balancer might receive traffic on port 443, pick a server using round robin, forward entire encrypted TCP stream without looking inside. If server 1 is down, it picks server 2 or 3. It doesn't care what the request is. Layer 4 load balancing application layer. What it does, load balancer works at the HTTPS level. Okay, bu TCP level'da işləyir, transport layer'da işləyir və TCP UDP transport layer'da load balancing edir. Bu amma HTTPS level'da işləyir və application layer'dadır. Bu ama incoming request'i oxuyur, reads application data, it terminates incoming connection, reads application data, header, cookie, request path, method, payload, and makes smarter routing decision. It then opens new connection to the chosen backend server and may also modify header X forwarded for. Verifiable TLS termination can decrypt HTTPS once at the balancer and forward plain HTTP internally. More CPU intensive because it has to parse and inspect application data. More complex configuration. You say you have app servers, video streaming server, billing, secure payment server. Load balancer 7 linear terminates TLS, reads URL path, routes video traffic to video server, and billing to payment server. It can also insert cookie for session affinity, do header-based A/B testing, enforce authentication or rate limits. Okay, deməli layer 7 daha ağıllı davranır. Intelligent routing or TLS termination. You need raw TCP UDP performance. You don't need to inspect or modify application traffic. Your app uses HTTP. Latency is critical. You want features like sticky sessions, A/B testing, API routing, authentication at the edge. At the edge for basic routing, reverse proxy internal for fine-grained routing and application logic. Horizontal scaling. Load balancer can also help with horizontal scaling, improving performance and availability. Scaling out using commodity machine is more cost efficient and result in higher availability than scaling up single server on the more expensive hardware called vertical scaling. It's also easier to hire talent working on commodity hardware than it is for specialized enterprise system. Disadvantage horizontal scaling. Scaling horizontally introduces complex and involve cloning servers. Servers should be stateless. They should not contain any user-related data like session or profile picture. Session can be stored in centralized data stores such as database or persistent cache, Redis Memcache. Downstream servers such as cache and database need to handle more simultaneous connection as upstream servers scale out. Load balancer disadvantage. Load balancer can become a performance bottleneck if it does not have enough resources or if it's not configured properly. Introducing load balancer to help eliminate single point of failure results in increased complexity. And single load balancer is single point of failure. Configuring multiple load balancer further increase complexity. Nginx architecture, hub proxy architecture, scalability, Wikipedia, layer 4, aynı hepsi oldu, layer 7, ya bu. Bizim buralar oxumaq olar. Load balancing computer nature of task, dependencies, static and dynamic algorithms. Neyse, bugün bu boyda şey okuyabilmeyeceğim. Bunu scalability for dummies. Biz buna baxmışdıq deyəsən, səhv eləmirəmsə, düzdür. Neyse. Qalanına sonra baxarıq. Oldu uşaqlar. Bugün hələlik sağ olun. Sabah yenidən görüşərik. Bugün yayını qısa edəcəm. Sabah qaldığımız yerdən davam edəcəyik. Sağ olun. Özünüzə yaxşı baxın. Sabah görüşərik.